one of the other things that I'm going to hopefully get a chance to do more of is help represent Steinway for some of these technical classes. Kent continues to be your point person for service needs. You can reach him on the phone, as well as Georgia Maldonado for Spirio related things. And I know that David Kirkland, I think, is still on the phone if you needed to reach out that way. But I'm also available in a more unofficial capacity to communicate with you and to troubleshoot anything that you're working through, or if you have questions, I'd be happy to answer them. I love talking about pianos. That's all I get to do all day. And I'm sure that you all agree, since most of you also do that, it's a great thing. My role, I've been with Steinway now for actually a little over 7 years. And I joined Steinway as the technical trainer. They were looking for someone who had Steinway experience and experience with teaching. And so I was at that time communicating a lot with Kent, and they asked if I would be interested. And 7 years later, here I am still doing what I can do with Steinway. I get to work in the factory, train the factory operators, work on quality, work on method improvements, work on tooling, gauging, all that stuff. Really very, very fun stuff. And I get to really see what some of the new developments are. And that's one of the things that I'm going to talk about today with you all is New York is actually implementing very soon entirely what you would probably call the Hamburg key block system. So this is the system which is quite heavily engineered. It's a little bit more of a complex mechanism. So we're going to take the time tonight to talk through how that system works, how to assemble it, how to regulate it, how to troubleshoot it, as well as, frankly, what most of the pianos out here in America still tend to be. Those are New York Steinways with the traditional key block plate system. So I'll dive into my PowerPoint and we can get going. So I'm going to click down here and we'll just see how this goes. Let's share this screen. Okay. All right, so hopefully everyone is seeing this, and if you're not, then I assume, Bill, you can tell me. We're going to talk about the key block systems. Now, this is something that most piano technicians, when we refer to it, we say cheek block. Steinway says key block. I don't have a good reason for why, other than that's what we've been saying for many decades. So difference in nomenclature, but we're talking about the cheek block. So what we're going to do is we're going to talk about the design and the assembly of each of these two different types of key blocks. We're going to talk about how we adjust it, how we regulate it, how we service it, and how we troubleshoot it. So let's sort of talk about what is the function of the key block. Well, primarily what it really helps with a lot is bedding the front rail. On a Steinway piano, we have what I guess we would call a reverse crown, kind of a smile on the key frame, which is about 1/32 of an inch. And we also have a crown going the other direction, I guess you could call it a frown, on the key bed. So it's sort of two circles, or I guess radiuses, that are only really making firm contact at what would be considered the center of each of those circles. And the key blocks come down and they will flex the key frame to come down and make contact with the key bed. We want to make sure that it flexes and comes down to make just the right amount of contact. We don't want too much. We don't want it to be too heavy, because while being down so that it's well bedded, we won't get very good shift when we push the unicorda pedal the key frame may shift over once, but it may not return, or it may be so sluggish that it doesn't want to come over all the way, which can also result in problems with hammer to string alignment if it sticks. So front rail bedding, it assists in helping the front rail stay well bedded to the front of the key bed. Again, in a Steinway piano, it also accounts for the forward and backward position of the key frame. If you take a Steinway piano and you insert the key frame into the key bed cavity and push it back all the way against the dags, your key frame is going to be too far back. We don't want our key frames making contact with the dags. We want to minimize friction. There's only a couple of contact points. We only want the dag to touch the top of the key frame and not have any friction against the back. So we intentionally leave some space, and this space also allows for adjusting our strike point. When we adjust the strike point, what do? We grab the key frame and we move it forward and backward in its entirety to achieve the best sounding strike point. And when we find that point, then the mechanisms inside the key block help us determine help us fasten that ideal spot in place. The key blocks also guide the key frame travel during una corda shift. As I was saying earlier, we want to make sure that we don't have too much friction. We also want to make sure that as the key frame travels, that it travels strictly left and right. It doesn't shift forward or backwards at all. And that is possible if the mechanism inside the key block is not holding the key frame pin securely. And of course, there are other elements that the key block also does. It holds the fall board hinges. It will retain the key end slip with those screws there in the front. So that, in a nutshell, is more or less what our key block does. Let's just talk a little bit about, I'm not going to give you a history lesson, but I'm just going to show a couple of pictures of a handful of older key blocks that are all Steinway key block systems. So this key block happens to be from right around, I would say, I think it's the 1800s, certainly before 19 something or other. This actually was just in the factory not that long ago as part of a restoration job. So you can see actually that there was at one time, New York Steinway did adjust the strike point using a screw in the same way that we see the Hamburg pianos do today. And then on the left, we can also see the bass side of that, of another type of key block system, which really is quite set in place. This is a bass key block, so it's much less necessary to adjust the strike point, or rather when one does, it really takes, in my experience, a good 1/8 of an inch to really get much difference of tone with strike point. And usually it has more to do with the sustain than it does with the attack. But you can see that on that left key block plate system that the channel is actually rectangular, and it's actually, if you really look at those edges, it's actually kind of rough. So yeah, that's sort of just a background on a couple of different key block systems. I'm sure that there's probably other things out there, but this was something that was at least available in the factory that I thought would be interesting to see. So let's talk about what we would call the modern New York key block system. This happens to be one of our crown jewel pianos. This is actually Padoke wood, kind of a nice looking veneer there. So we have the brass key block plate system here. And you can see a lot of similarities from what we had with the old key block plate systems and what is going on with this system today. We have a brass plate. We also have brass screws. So we can see in this picture, there are 2 screws that are already installed in the top. And there are also 2 holes on the bottom that actually have not been drilled and inserted yet because this piano happens to still be in production. So the reason for that is you can see that these top screws are in a place with the key block plate. Let's see, I'm going to try to say this in a better way. You can see that behind the key block screws here, that there's a little channel that can be used to slide the brass plate left and right to adjust the strike point. And once that optimal strike point is found in the factory, then these other 2 screws, holes are drilled and the other screws are put in. When you see these key blocks out in the field, these are already going to be installed. So this function tends to be a little less of a moving feature, but it still is possible to adjust, and we can talk a little bit about how we might do that. Another element with the New York key block system is the key block paper. It's kind of a red-ish, kind of a fibrous type of paper that can be peeled or sanded off in layers. We'll talk about all of the functions of that system and how we can service it optimally as well. Now, I know I'm kind of barreling through here, but I'm just trying to sort of give you a quick overview, more or less, of how each system works and how each system accomplishes the same goals. And then we can get into a little bit more of the nitty-gritty with the New York and then with the Hamburg after that. So let's see here. This is the German key block system design. There is a stainless steel underplate, which is not that visible from this picture. It's being covered by this big brass block, which is the next point here. There's a cylinder above, which is used to press against the key block cutout. There's a tapered pin, which is in the shadows. It's a little bit difficult to see. And there's also a plastic roller, which is basically a plastic round piece which spins on a pin. So it moves quite freely, even if there is excessive downforce with the key block system. There's also the large brass screw, like we were seeing in the older New York systems. This screw in the front can be used to make fine adjustments with the strike point in the treble. Okay, this is just an underside view of what that same key block system looks like. This picture is for a treble key block, and we can see this slot cut out in the bottom that as the entire mechanism is adjusted with the brass screw, the entire mechanism moves forward or backward along this slot to move the key frame. Okay, on the base side, it's almost the same, but there is no brass screw in the base to adjust the strike point. Again, as I was saying before, it's very rare for one to have a need to adjust the strike point in the base, but should one find the need to do that, it's done by loosening these screws here on the bottom to slide the whole mechanism left or right and then fastening them again. So a little bit less easy to adjust in the piano the way that the treble one is, but again, once it's set, it's very, very rare for the need to reset it again. Okay, so that's sort of an overview of both systems. Before we go much farther, I want to take the chance to do us all, I think, a little bit of a favor and just talk about the easiest way to remove a Steinway fall board. I think that we've all probably been there where you're trying to remove the fall board in a client's home, you know that the key blocks are attached to the fall board. On Steinway pianos, they're really just hanging off of a pin. You try to pull them out, and then one falls off and the other falls off, just like a set of weights in the gym. And I know that we've all been red in the face over that, and I myself have even caused damage from that happening. So I just want to talk about the way that we really want to, what is really an optimal way to remove the fall board. We want to lift the fall board with the key blocks still attached. Now, obviously, we would loosen the screws first. So the screws which come and fasten the key blocks from underneath, those would be removed. Once those are removed, then the whole mechanism is free. And we would lift the fall board and set it down on top of the sharp keys. Then when it's in that position, the keys are holding the fall board up in a way that it's possible to remove each of the key blocks individually. And then the fall board can be removed after that. So what I have up here next is just a quick video of me doing exactly that. When I was doing this earlier with Bill, just troubleshooting some of the video, there was a little bit of a humming or a buzz that might again happen right now. So I apologize if it does, but hopefully you can work through it if it does occur. So let's watch this video and we can see me doing exactly as we say in this instructions here on this page. So coming up, lifting the fall board, lowering it onto the sharp keys, removing the treble key block. There's some dust there. Removing the bass key block, and now the fall board itself can be removed. Okay, now that's phase one. Phase two is you have to be able to put the fall board back. It's no easy task to do that, being that the key blocks are free moving. So let's talk about how we also put it back. Okay, so the first thing, which is the most important, as we were saying earlier, the key frame, if you're sliding it in and out of the piano and servicing it, you may not have the key frame in the ideal position for the key blocks to simply fall down on top of those key frame pins to have the correct strike point, the way which the key frame is supposed to sit in the key bed. So we want to make sure first that I guess we'd call it a dry fit of the key blocks. We would put them into the key bed on either side of the key frame and just position the key frame so that it's in the ideal position. It's in the correct position according to the key blocks. Then we will remove the key blocks again. We would then place the fall board back onto the sharp keys and then place each key block back onto its pin. And then we can lift that entire mechanism carefully and put it back into the piano. So here's a video of that taking place. Key frame has already been established in the correct position. The fall board sits back on top of the sharp keys. The treble key block has been placed in. Lifting the bass now gets put in place. And now the entire mechanism is lifted, slipped over those springs there on the side of the rim, and we have insertion. Okay. I'm going to keep going on for a little bit. So I was having a little bit of a challenge trying to see any sort of a chat when I'm giving this PowerPoint presentation. So I'm going to keep going through a handful of the New York things. And then when we come to a point with, we come to a stopping point at the end of our New York segments, then I'll pause and we can review the questions and chats, since I'm not having the ability to actually look at that right now, I think. So I'm going to keep going, and Bill, you let me know if something needs to change.
I'll do that, and yay, there was no buzz on that video.
Oh, okay. That's good to know. I think, actually, now that I checked, I think that the sound might have been turned down on that one, which might have been the reason. But Okay. All right, so let's keep going. So there's another feature that Steinway key blocks now have, which is making its way into the market more and more. From about 2016 onward, we began using a machine screw insert for the key blocks. So we're all familiar with the wooden screws that one uses traditionally to fasten the key blocks. There's really, I guess, nothing particularly wrong with those, but we've all experienced problems with that screw stripping out, with it being tightened so tight that it can't be undone. We went to this machine screw insert to try to have a little bit of a more similar function and form as our Hamburg manufacturing side was already using. So what you see in this picture here of my hand is what that machine screw insert is. And it's really just a metal piece with tapping threads on the side of it, which go into a hole which is pre-drilled. Now it's installed, I'm going to start this video as I keep on talking, using a 5/16 hex wrench. Okay, you can see on that key block there the hole that it goes into. I removed this one, so I'm turning it left before I turn it right, just so I don't end up cross-threading it. But it simply gets turned in with the hex key, and once it's fastened in place and it's flush to the key block, we can see that on the inside there that those are just past where that hex insert is, the threads for our machine screw. So we now use machine screws for all of our key blocks. Now it is still a traditional slotted screw head. Hamburg, I think, uses still the hand loosening and hand adjusting mechanisms. As of this point, there is not any talk on the New York side of adopting those. Not to say that we wouldn't someday, but as of right now, that's not going to happen. We're still using the traditional screwdriver, or the traditional slotted screw. Just as a point of clarification, however, in some of these videos that we see, you're going to actually see me using a machine screw, which is turnable by hand, just sort of almost like a wing nut of sorts, that just makes it easier for me to demonstrate what I'm trying to get across. It's something that in the factory we tend to use a bit because it's easily removable. It's not that beautiful looking, but it gets the job done. So you'll be able to maybe notate the difference between those two things. All right, I'm going to keep on going here. Still in the New York side of things, let's talk a little bit about that key block paper. So in the New York system, one of the thinking or the thoughts behind the key block paper was, one, to be able to adjust the downforce of the key block on the keyframe pin by removing layers of key block paper. And theoretically, one could also glue layers on to achieve the correct amount of downforce. It's also possible to do much of that by adjusting the key block plate, but we also figure this is a very simple, easy way to do it with paper without messing with the metal system of the brass key block plate part. Now, in this video that you're about to see, I'm just going to show what one does to glue on that key block paper. So I'm going to start that video here. We can see on the right that there's a little bit of a bevel to the key block, and that's really to provide clearance from the corners of the rim to make sure that as the key block is fastened in place, that any of the finish buildup doesn't interfere with the fastening down of the key block plate system itself. So this is that red fiberboard paper. You can see how I cut it a little bit short so that it can be centered over the key block, accounting for that bevel. We really just use a standard PVA type of glue to fasten it to the key block itself. It just fits right on like so. And that's all that there is to it. Now, there has been talk of one other thing that system supposedly does, and I would say that maybe it was true of our key blocks back in the day, that if we don't have a perfectly flat surface on the bottom of our key blocks, then as the key block is fastened, we may have unequal pressure. Say the key block was maybe a bow underneath, and so now it can rock one way or the other. Using the key block paper was one way to ensure that that didn't happen. Then essentially all we're really having is contact at the key block paper and contact at one other point if it wasn't perfectly square. And as the screw comes in, it would hold it in place. Today, that's really not the case. Our machining is much more precise, and we're able to really achieve quite straight surfaces. So when we get into the Hamburg system, you'll note that there is no key block paper. There's nothing underneath on the bottom because we don't really need it. It's not really integral to what the Hamburg side of the key block system is. So you'll only see this on the New York. So let's just talk really quick about the brass plates as well, a couple of the design features. Now, if you look at this picture, which was taken sort of in a magnified view, you can see that the walls of this brass plate are angled. We do that to minimize the key frame pin friction as it slides back and forth during shift. Now, one can't really see it in this picture, but the back wall also has an angle going sort of away from the camera, as one would sort of go down. So all angles sort of sweep out to minimize that friction. The key frame pin on the New York system is a square pin. So that square pin fits inside that square channel. So we have a very precise fit. It can also be pretty fidgety to make it really work just the right way so that it is held in place, but it's not held too tightly in place. And it cannot be so loose, otherwise we can have clicking problems, sliding problems. It really is an unforgiving system. It can be challenging to set up, but once it's set up, it really will work for quite a while. So square pin must be straight. When I say straight, I mean straight in all senses of the word. So we want to make sure that the pin is straight in the horizontal fashion. If the pin is pointing upwards or downwards, we're going to have varying contact with the key block as the key frame is shifted with the unicorda pedal. Neither is good, whether we get more friction or less friction. We got to make sure that it's the same amount of friction. And of course, forward, backward, as well as twist, all that stuff needs to be straight because we're working with a lot of square edges. Now, to achieve that good fit with our square keyframe pins, we occasionally have a need to file that channel to get the correct amount of size so that the pin fits with just the right amount of friction. So in order to do that, we would file it with a file like you're going to see here in this video. Now this file has a rough side and a smooth side. We want to place that smooth side facing down so that we don't affect the bottom edge of the channel. Now you can see as I sort of move that file left and right that there is sort of movement to for it to be at that angle that I was referring to earlier. So I'm cautiously removing a little bit of metal from either side to achieve the correct width. So the only direction that I can go with this is more open, further. If the key block plate is too tight on the pin, then what I would do is I would file it with a file in the fashion just shown in this video. Now, what do we do if it's too loose? If it's too loose, then we would swage the brass, and I'm going to show a video here of how that's done. I like to take a ball peen hammer and position it in a way that I know that I'm making good contact, and then give it a nice hit. And you can see in the reflection there that we got a nice little dimple on that. So what that really did was it swelled out. Didn't really swell, I guess. It deformed the brass and moved that that wall out, so it sort of ballooned out. It's very unlikely that it moved out in an even fashion so that it's square to the pin. Hitting it with the ball peen hammer and another hammer almost never results in the perfect amount of friction with the pin. One almost always has to follow up with the filing like we just saw in the last video to achieve just the correct amount. So we're usually swaging it to too small and then filing it back to the correct size on the pin. Okay, so this video that we're about to look at here is one way that we would check to make sure that we have the correct amount of play of the key block on our square keyframe pin. This is a view from above. We can see a little bit of a wear mark from that key block already making contact. So I want to slide that forward and backward and make sure that I'm not feeling any burrs or any problems like that. Okay, so if I do, then I may want to address that that key block plate with a file to make sure that it's moving smoothly. And then I also want to check sideways, forward and backward. And I should only get rocking, like you see it's kind of tilting forward and backward. If I'm able to actually slide it side to side, then I have too much play from side to side. And we can even see in that picture just, whoops, in that picture just how much contact. Oh, let me rewind that one more time. Pause it. There we go. We can see that's actually quite worn in. That to me would actually be a sign that maybe there's a little too much down pressure of that key block plate making contact with the keyframe pin. And even to that end, we can even see that in this spot here on the keyframe pin, it does look like it's a little bit more burnished. So that would be an indicator that maybe there's too much contact. It's a little bit too heavy. Of course, the real decision will be if the front rail is bedded, if it can shift, but it's a visual indicator that we wouldn't want to discount. Okay, so let's talk about now, knowing what we know about the function of bedding the front rail, what we want to achieve with the key block downforce. Okay, what we're looking for is the key frame to be forced down by the key block to make just enough contact with the key bed and not too much. Now, the way that we would gauge that would be within the last half a turn of your key block screw. Now, this is true of even the wooden screws as well as today's machine screws with their key block plates. If you can get it to the key frame to come into contact with the key bed within that last half turn, then we know that we've achieved our result. So now I'm going to play that video for you showing what that should look like. This video, I think, is going to be the first one with audio so we can hear that tapping. So we'll see if we get that buzz or not. Hopefully, if it does happen, you should still be able to get the point. you can see that that contact is really quite minimal. It really only stops knocking right as the screw finishes turning in all the way. Having it tighten earlier than that is almost certainly going to cause friction issues with your shift, with your front rail bedding. You can bend your keyframe pin down, all that stuff, unless you're making just minimal contact with that system. So what do we do if it's not working for us? If it's not doing exactly like that video showed? We have to figure out how to get it to actually function in the way which it's supposed to. So how about this? We have a symptom. The key block is fully fastened, but the keyframe is still knocking. Well, the cause is probably that the key block plate is too high, or it's not holding the keyframe down with enough pressure. So the solution to that would be, easiest thing, we can remove a layer of paper from the front of the key block. So no matter what I do with the fastening, it's not closing. I'm going to take off the key block. I can remove paper. Now, I can actually, it's possible to do it by hand. You can get it purchased with your fingernails. And you can see that it's beginning to just peel off. Okay, I can peel off more layers, you see here. Just a little bit more can be made to come off. And there's also a third way that one can adjust that, and that is look for sandpaper. It's possible to sand away some of that paper as well. So those are three different ways, really two different ways that one can remove that paper. Now I've probably removed far too much. So it's not going to have a problem now. Oh yeah, it's definitely closed now. So in this case, we may end up actually having too much down pressure, but in this case, you want to sort of very carefully remove a small layer after small layer to really just lightly bring that key block pressure down on the keyframe to make just the right amount of force and connection. All right. There's one other option that we can pursue here, which is maybe less common. Let's say that you've removed all of the key block paper that there is, and it's still knocking. Well, you still need to find a way to get that brass plate to come down further to make better contact with the keyframe pin. And so we would maybe just use some veneer to do that. So here I am just sort of marking out more or less the approximate length and width of what that, what the top of that key block plate size is. This is happens to be just, I think it's 1/32 of an inch thick maple veneer. Maple tends to work pretty well most of the time, to be pretty well hidden. So I'm just putting it right up against that spot that the plate would otherwise bear against, and that brings down the plate just a bit further so we can make sure that we're having that downwards force. And then we can still, you know, if there's paper in here, then we can afford then to maybe put the paper, if there's veneer here above the plate, then we can afford to put paper back on and bring down the down force again with the paper. It's much easier than trying to, say, swedge the top of this brass and then file it again. Putting in the veneer tends to do a pretty good job of bringing it down how we need, and then we can adjust using the key block paper after that. Okay. Okay, I'm going to go on to another one here, and once I get through a couple of these different troubleshoot ones, we're not too far away from a time we can talk through a couple of questions, okay? So here's another one, sluggish or sticky shift, okay? There could be a couple different causes. One of them could be a bent keyframe pin. We were saying that earlier. If the keyframe pin is bent up or down, we can have too much contact as the keyframe shifts. The key block plate might be too low. That's a possibility. It's also possible that there could be the channel that the pin travels through is too tight, okay? So depending on what the actual cause is, it could be any of these three. There are a couple of different solutions. The first one is we always want to make sure that that pin is straight. If it's not straight, we need to straighten it out. One can use pliers oftentimes to simply pull it up and to straighten it out. If it ends up becoming too loose, then we can always plug and re-drill it or shim it with some veneer to make sure that it's tight and in place. If the problem is the key block plate being too low, then we can always add more paper to the front. And again, the key block paper is really the key to adjusting downforce here. I would recommend that if you don't have it, that you acquire some. It really is a quite handy thing to have when servicing New York Steinways. And of course, if there's any filing which needs to be done, then we can file either the sides or the top of the channel to have the correct amount of. Here I am, again, filing. We can see the rough side and the smooth side. We're going to do the smooth side up against that channel. You see the way that I'm the file. This is the easiest way to sort of open up the channel with just a little bit of force. You can hear I'm removing just a little bit of metal. And that's all it would take if most of the time there really is just the correct amount of contact on those keyframe pins. Okay, so let's just do, I think I have just one more here, and that is if we happen to have a ticking noise on the shift, kind of a noise when we push the una corda pedal. Oftentimes that's due to the pin itself is actually clicking against the pin because the channel is too wide. So in order to fix that, that's a great opportunity for us to swage that key block plate. And it's possible to do it without really disassembling much of the instrument. You can hear here, as it's being wiggled up this side, that by placing the key block on the floor is really the best place to do it. Put a nice little swage there to spread out the brass, and in this case, in this video, I actually got pretty lucky. It really ended up working out just right, not too tight. Most of the time, though, you're going to find that when you swage it, it's going to be a little bit too much, and then we'll follow up again with filing again, just like in that previous video. So those are probably the main. Oh, you know what? No, I do have one more, and it's a big one. So you know what? Let me talk about this one as well. So let's talk about strike point. The key block doesn't place the keyframe up at the optimal strike points. I'm going to play a video here of checking for the strike point, trying to adjust it correctly. I'm going to, essentially what we do is we remove the key block. We'll move the keyframe forward and backward to get the correct, strongest tone, not only at note 88, but also the other notes within that top octave or so. We want to make sure that all of them sound strong and we find the best spot for it. Plug is removed. On this top rail there, it's easy to grab to it. And all the while the base is, the block is still in place. We found the left foot seems to be the strongest point, and the key block goes in place, but it didn't quite fall down into place with its own weight. So the strike point is not adjusted correctly on this piano, so we need to adjust for that. Okay, what we can do is we can move that plate left and right. So again, we would remove these two bottom screws and we can make some adjustments here. So I'm going to play this next video. Now in this case, actually, we're going to see even that the key block plate has been maxed out. You'll be able to see it. I'm going to place a pencil line here so I can see where I'm starting and I can see where I'm finishing. A little bit looser. So I want to pull it back a little, make it even, carefully, make a small adjustment that way. So I'm wedging the key block as far back as I can get it to go with a screwdriver, sort of forcing it over with the tool because it's just about maxed out with how far it can go. If it being in that as far back as it can go position doesn't work, then something else has to be done. Then we would actually file that channel where the adjustment point, that round spot of that key block plate is. We want to open up the length of that channel. It's just a little round tile. Rubber plate. Really work just fine. See all that material we just and it really doesn't look like it wasn't supposed to be, like it had been filed. Really, we want to do our best to try to make things look like nothing was done to them that shouldn't have been done, or that should have been done correctly from the beginning, right? So now that we have that, we've moved that key block plate back. Okay, let's try it again. Now also something that can be helpful to keep an eye. Keep an eye on the key frame front where it makes contact with the key bed. The raised portion, look at that, right in place. That's in the right spot. I was saying just earlier, it's helpful to have one's eye at the front of the key frame where it makes contact with the key bed to sort of see where things are moving and have sort of a visual correlation with what you're hearing, so that you remember, say, when I'm adjusting C8 and I found what I thought was the ideal position, as I also check the strike point slightly lower down in the high treble, I want to keep that same reference point in mind to see if that also sounds good there as well. Okay, so I'm gonna just go out here for a quick second here and go back to what I was doing. Are there any questions that I can answer?
We've got some that go back all the way to the machine thread screw. Do you know is it metric or is it using the standard TPIs? Do you know what the threads per inch on that are?
You know what? I don't know. I could find that out for you, but that's something that is not at the tip of my tongue. I couldn't tell you if it is metric or imperial. Yeah, I'm sorry about that. I don't know. Hopefully, the key block screw that comes with the piano is with the piano, and you won't have any problems there. But
yep, but you know how that works. Other questions seems to have been answered here for folks in the chat. There's the relationship between the balance rail and the front rail knock using the guide the guide pins. If you, I can think of which would you set first. at doing this process to when you were bedding the key frame, or assuming this, depending on the process where you are. I mean, this is going beyond the question, but there's
Right.
got to be a relationship between your two crowns, the reverse arcs and the balance rail and the front rail.
Correct. So when one is bedding the front rail, we would expect that the balance rail studs have been turned up so that they're not making contact with the key bed. We're only having contact with the back rail and the front rail as we're adjusting those key blocks to have the correct amount of downforce. After that's been achieved, then we would go through and bed. And if it's always a good idea to make sure that things are still functioning the way that they should, we would double check to make sure that things are still bedded correctly without too much downforce at the front. I have seen that the TR studs can be turned down so far to affect the front rail bedding, but by and large, if you're bedding the key frame in, if you're not over bedding it, I guess we could just say, you're really not going to find too great of a change at the front rail.
Okay. And John, I'm assuming that answered your question. Just nod if yes. And the other question was about the fiberboard. Is that a Steinway part that can be purchased there, or is that?
It is a Steinway part, and I can maybe a post meeting I can send you, Bill, what that part number is in case anyone is interested.
And I know that Steinway has a PDF parts list that's available for anybody that wants it, right?
That's correct.
So, and that's parts at steinway.com, I think, is just
also correct. And I think that, again, this is stuff that Kent is more involved in than I am, but there's even a technician login page now where you can simply purchase off of a website once you log in.
Okay. Has any discussion about converting the fall board cheek block configuration so that the fall board and blocks are independent from each other, as with most other makers?
There has been no talk. I guess that
that answers the question. Not at this point in time, I think, is the correct answer.
Yeah, at this time, as one who services pianos, I can appreciate the challenges of it, but as of this point, there's no talk of stepping away from what has become known as the traditional Steinway fallboard key block system.
Okay. I think I've gone through all. I don't see any other questions, and I think the other ones that have been asked.
Now I see Cy.
Cy is doing something. Okay, there you go. Unmute yourself, Cy. Go ahead.
I've seen on older Steinways, people can take out the key block screws and take out the fallboard, key blocks, and key slip as one unit. Mm-hmm. And usually successfully on an older piano where there's sufficient play. And it occurred to me that possibly that was an intentional design so that, the key slip would hold the key blocks on the end. What do you think about that, using that technique?
Yeah, I really don't have any problems with using that. I know that one of our selection room technicians in particular is fond of using that method, and that's his go-to way. So there's no problem with doing it. I find that usually in order to do that, you need to have space set out to set down that entire assembly. So you tend to need a little bit more room to do that, where if you separate the parts, usually you can fit them anywhere that you need a little bit more easily. But yes, it's an absolutely valid way to disassemble the system.
Alan, maybe I should, where's Alan? Oh, well, Alan was working on a Steinway for a client who is an engineer, and he's wondering why Steinway is still using slotted screws. What should I tell him?
So actually, Steinway is beginning to embrace the times in that we are adopting more and more modern screws in different parts of the piano. Now, Hamburg already uses that, I think I'll refer to it as an elephant ears screw underneath. They also use, well, actually, I don't know if you've noticed this or not, big deal. Steinway, New York went to using Phillips head screws for its stack screws about 3 years ago. And yeah, right. So, and more is coming. So there's, in fact, not just Phillips, but it would, we're also looking into adopting more of, just like the Hamburg piano already has, the posit drive head, which looks a lot like a Phillips. You can use a Phillips screwdriver on it, but a Phillips, a posit drive screwdriver works even better, fastens quite well. So we're getting to more and more of that. A couple of things are going to remain to be slotted. Usually we're using slotted because it's traditional or because it looks good.
Okay. Okay. All right. That's the end of the list that I have, Ben.
Okay, so now we'll get into the stuff that I think most people are probably more interested in, which is the German side of the key block design, and what we're going into with all of our New York pianos here, and we'll continue seeing more of in the near future. So I'm going to go again here and share my screen. Going back here. And let's see here. All right, are you seeing this okay?
Good deal.
Yeah, okay. All right, so let's move on now to the German key block system. All right, so right from the outset, there's a fundamental difference. The German key block system, the key frame pin is round. And having it round actually allows for a number of advantages. One of them is the contact point is minimized. Instead of it being a flat surface of one side of that square, we're only touching on a radius portion. The roller system also allows for a little bit easier movement. So we're going now to this round system, and you're going to start seeing more of these keyframes that have a round pin. So what I'm going to do next is I'm going to sort of show you how Steinways that have been in manufacturing, or have been manufactured since not that long ago, about 2019 and onward, how they are assembled. So what we're going to show here is a assembly of the system for, this is the base side of the German key block hardware. We can see we have that steel underplate which fits into the cutout of the key block, and so, and it can be slid backward for that strike point adjustment with those screw holes you see there on the bottom. To fasten that steel plate, we take the two Phillips screws and insert them into these two holes here. Generally speaking, when they are assembled, we set them up so that they are centered, so that if one needs to adjust in either direction, either forward or backward, keyframe pin is installed in the fashion that, we start at the center, you can go in that direction. So, in this video, I'm going to loosen it a little bit, so we can see, there we go, we can slide that whole mechanism forward and backward just a little bit. Okay, there's also another screw which goes in the center. Hold down the steel plate from the other side. I guess we can put that back. block. And once we have that position set up centered, at least here in the factory, then we'll fasten those screws to the Next up is our brass block. There are two channels which fit over those two nipples that you see on the steel plate. But before we start assembling that, we want to install our tapered pin. So on the left side, you see this tapered pin. Using a 3mm hex driver. That screw inserted into that hole. And it's turned into the point to where that tapered pin just barely makes contact with that cylinder that I just tapped with my finger. You can sort of see it in the light, just right in there. Now, if I remove that cylinder, just metal pin, more or less, with a little bushing. If you look through, you can see just the tip of that tapered pin. Right, so that's sort of bottomed out. Now, if I were to turn in that tapered pin, watch how the cylinder rises because it bears against the angled portion of that tapered pin. You see how it's beginning to get higher and higher? Okay, so just by turning that hex driver, I can change the amount, that height of that cylinder. Now, I can't go the other direction. It's not a sprung system. I can turn the pin back out again, but the cylinder stays up. I have to push it down manually. Okay, so that's the assembly of that portion. So now it fits in like so, and that cylinder bears out the block. The other two Phillips screws fit into that channel and fasten the brass block down into place. And there you have it. That's a fully assembled base German-style key block system. Now, I'm going to show you another video of the treble side because it's almost the same, but not quite. And maybe looking through the treble side, you'll be able to catch a handful of the differences and see what the similarities are. So here's the video for the assembly of a treble key block for, again, Steinway's 2019 and so what we have now is actually that brass screw needs to go. That's the big difference right there. There's already a little bit of Vaseline micro Teflon on it, but we actually install that in the factory. Okay, so you can see that that brass screw is being inserted into the hole. And as I turn it in, what I'm looking for is this channel right here to be more or less in line and centered with that center hole right here. Okay. And we also want to make sure that we're not proud of the key block. That screw needs to be inset or flush. Now, the next element on this, hold on, I'm going to pause because I'm getting ahead of myself during this video. Let me just rewind it for a quick second here. We can see that what's different on this system on the treble side is there's this little brass piece which fits around this smaller part of the cylinder on our brass screw. That's what sort of grips on to it just there. So when we insert it, we want it sort of in place. You also want to see how I'm installing it from the bottom to slide in that channel there first. You can manage it. Okay, so it's in there, and then you sort of want to move it left or right until it finds the right position. It should just pop down to the blade. It really should. If it doesn't, then you want to slide the blade back. So we can see now that just that those two mechanisms are in. If I turn that screw, the whole assembly so far slides forward and backward. Okay. Now we're going to go to the other parts of the assembly, which is essentially the same as in the base. We have that screw here that goes to the center that has the key block. Note also that there are pins here that the plate from blocking as the mechanism is adjusted accordingly. Once again, we have those panels that fit over each of these nipples, facing down, okay, which means that the tapered pin needs to come in on that side. So both sides are threaded, okay? For ease of manufacturing, both sides are threaded, one for base, one for couple. We want to make sure that the pin is on the correct side. Otherwise, we won't have the correct amount of downforce. Here we are inserting that tapered pin again, getting it just making contact with the cylinder, pushing it down and pressing it up against the top of that block cutout, and fastening the Phillips screws. All right, so now we can see that the full assembly mechanism can actually shift left, right, or really what amounts to backwards and forwards. Now, there's something in that video that is a little bit of a tip-off that there's something wrong with this one, which we're going to get into when we get into troubleshooting. If you caught it, great. If you didn't, then you'll see what we're going to get to here in a second. Okay, so let's see. I don't think we need that. All right, so how do we adjust that down pressure? So the whole mechanism that I showed you in the earlier videos of adjusting that tapered pin to get the correct amount of downforce, I want to talk about how we want to set that to work optimally. Okay, the first step is we want to make sure that the Phillips screws are not too tight. If they are really fastened really snug, then they're going to prevent this whole brass block mechanism from sliding down to increase the pressure on the keyframe pin. So they need to be snug enough to hold the block against, or I'm sorry, to hold the brass block against the key block, but they can't be really tight, just tight enough, okay? We want to take a 3mm hex drive to insert into the front of the key block and into that tapered pin. Now, in this slide here, we can see a picture of the driver that we prefer to use here in the factory. It happens to be the WEHA 367R. It's a 3mm ball end hex driver. So the ball end means that you can insert the driver at even a bit of an angle and still get purchase on that hex set screw and still twist it. So that ends up working quite well for us. There are others that are out there. Even a hex key will do the trick if it's the right size, but this is a really convenient tool to have. We want to turn it clockwise to lower it. Essentially, we're inserting the screw deeper, and the thicker part of the tapered pin is making contact with the steel cylinder, which is going to force it up. But it doesn't get forced up. It actually bears against the key block cutout and forces the brass piece down. Now we have to remember that if we get too much down pressure, we want to loosen the mechanism and reset it. You can't just turn your hex driver counterclockwise to get it to loosen up. It doesn't work that way. It's not a sprung system. Once it's down all the way, then you have to loosen it to push it back up manually and then bring it back down once again. So I'm going to show another video here of what we do to turn it down, and what we do if we need to reset it. That hole there, which I wasn't able to really show in the light on this video, inside there is that screw, inserts right there to the mechanism. By twisting it in a clockwise fashion, we're going to watch this space right here get bigger. As the cylinder bears against this cutout, this old brass mechanism goes down. That's getting bigger, bigger as and we can see that the screws are actually getting closer to the edge here on the brass block. Now, if we want to go up, I'm putting it counterclockwise now. Nothing is happening. We have to go there. Okay? So we have to be sure that if we needed to go up, we need to loosen those two Phillips screws. Then it just goes back up. Press. You can then fasten down the screws to be snug again. Now again, not too tight. And then we can proceed once again with turning the key block plate mechanism to have the correct amount of down pressure. All right. So now I'm going to show you what it looks like in a piano. Really, the whole system is exactly like we saw from the side without a keyframe. But in this case, we're actually going to adjust it and see the keyframe itself close as we turn that screw down into place. All right. One thing that we want to be sure that we check for, once we've gotten that downward force to where the keyframe ceases to knock, we want to be able to make sure that there's not too much downward pressure on the keyframe pin, otherwise it can be bent down, although we found that it tends to be a much more forgiving system than the traditional New York Steinway brass plates. But to ensure that there's not too much pressure, one would say take their fingers right here on the front rail and press up with the force that you can manage with your hand, and you should be able to, by continuing to knock, still get a knocking, slapping sound to open up the keyframe. So in other words, you're just checking to make sure that the key block system is only lightly holding down the keyframe pin. So I'm going to show you this video and we'll see how this. Here we are. You can see that it's already up all the way. Our Phillips screws are not too tight. Okay. I'm going to use that hand turn screw. Tapping it down, and right now, even with the plug screw fastened all the way, it's still open. So I'm going to take that hex driver and insert it. Start twisting. There we go. Close. Now, I want to make sure it's not too much close. So, with a little pressure. I'm pressing, I'm lifting with my fingers to try to get that pressure so it's, we can see that it's just making light contact, and we can see now just how much the whole system moved. It was all the way up before, now it's just a little bit open, okay? So now that one is set. Now let's also do one for the treble. We can see what that one looks like. Making sure once again, those screws are snug, not too tight. Make sure that's all the way. Okay. Put in that screw as we begin. Tapping. Knocking. I'm right-handed. I find it easiest for me to tap and even turn with my left hand. I'm going to reaching over. Take a little bit more work. Here we go. And with the lift, push and lift. Make it knock. set. We can see what that space is, how far it's gone. Just a idea, make sure it's tight. See a problem, but never hurts to fasten it. Okay. All right. So let's talk about how one can set the strike point. Now, one would think that it would really be quite straightforward. All you have to do is just put a screwdriver on that big brass screw and turn it forward and backward and get the best strike point. And yes, that is absolutely correct. It can be done that way. However, I find for myself, and I think that I'm not the only person here, find that if we only adjust the strike point by using that screw, it tends to move rather slowly. And tracking the change for the strongest tone can sometimes actually be a bit difficult. So in the event that that is the case, there's a way that we can still set the strike point in a way that we know is correct, but still use that front screw mechanism. So let's just go through this process here. We would remove the key block, and we could manually adjust the keyframe for the optimal strike point. That's just like in the video that we saw before. Here's one of the differences though. We would draw a reference line on the keyframe position on the key bed, just with a pencil. Then we can refasten the key block, and then we can actually turn our strike point adjustment screw until the keyframe is perfectly in line with that reference line that we just made with the pencil mark. And then if you want to, you can make small refinements to the strike point after that. Here's not quite as good for you. You'll just have to take my word for it, I guess, that correct. So we can see it move here. Looking at the front point. So this tended to be the strongest point on the key bed. So I'm just going to take a pencil and make a real small line right there. So I know that that's the position that I want my keyframe in. Now when I insert the key block, you can see that I pull the keyframe forward. So in order to get or return the keyframe to that optimal position, I can simply take the screwdriver and turn it in until I'm at that optimal point. Now if I make some full refinement back from that point to get the optimal strike point. Okay, so now that we sort of talked about the assembly and the regulation, how it's supposed to work, let's talk about what we need to do when it doesn't work. So here's one. The keyframe becomes unbedded when the strike point is adjusted. The cause of that would be that the steel underplate is not being guided sufficiently by the pins. So these pins that we identified earlier as helping the key block plate move correctly forward and backward, they could be installed too low. On some pianos, you may not even find them in there. So in that event, there's a couple things which can be done to fix that problem. One of them would be the easiest one. Eliminate the gap below the underplates and the key block pocket with veneer. And I'll show you a video of what that is shortly. Or if you're able to, and this takes a bit of skill since these pins are pretty tight, if you're able to pull the pins up to help guide the plate better, that's an option as well. But in this case, let's take a look at it. We can see that the whole mechanism is kind of rocked, forward and back, forward it leans one way, backwards the other. So one way to help get around that, if we really can't do anything about pins is we would remove the underplate mechanism, and an easy way to do that is by sticking a screwdriver underneath there. And then we would want to increase that space right there where my finger is just pointing. And that's just what we're doing, is we're building up the key block plate to have the correct amount of contact so that it really can't be moved, can't be allowed to rock. It's allowed to rock because there's a gap essentially underneath here because the pins are not in the right place. So here I am sort of just cutting out a makeshift shape for what the underside of the key block looks like. And we can see, yeah, plastic overhangs. Off. And then what we have then is essentially just increase in the overall thickness of that block. So you see it's sitting just like this. It's going to blend in up. Slide that in place. Move the plate, find the correct position. Here we go. Comes down in place. That veneer is now filling up the little tiny gap that the pins were not helping it guide against. Now, as the mechanism is turned, the whole thing just glides back and forth. Easily. Without wobbling. So veneer is a great tool to help us with a number of key block problems. First and foremost, even on the German key block systems, if you come across this issue, oftentimes it's because there's a gap which is allowing the whole mechanism to shift. All right, here's another one. The key frame is embedded, or the tapered screw seems to be missing. That set screw that we often want to adjust just doesn't seem to be there. That seems to happen sometimes. Sometimes the tapered pin is not present. What actually seems to happen is you want to check to make sure that that pin isn't maybe on the other side of that brass block. I was saying earlier that both sides of that block are threaded for ease of manufacturing. One of them is meant for the treble, the other is meant for the bass. So if it's not there, then there's a good chance that it can actually be on the wrong side. But if we disassemble them, you just take apart those screws and remove them. We see nothing there, but the other side, aha, there's the tapered pin. We would want to then take this out, put it on the correct side. In the event that is missing, it's always you've got to replace it. But oftentimes, not something that one necessarily think of. That the tapered pin is there, but on the wrong side. Yeah, but you never know. It might actually be. And obviously, once you have that set, then you can actually work front rail bedding. Go and fit. All right. A couple other things. I don't have pictures or videos for them. We can just talk about them conceptually. They can happen. Here's a symptom. The key frame is embedded, even when the tapered pin is maxed out. It could be then oftentimes that the pin, which is in the key frame, has been installed too low. The way to fix that is, well, there's a couple things which could be done. Actually, no, I think did I make a video? I just I don't know if I did or not. Okay, so I actually have a picture here. I guess this didn't pop up earlier. We can, yeah, we can always put veneer here to bring the whole mechanism down even just a bit more if you want to have more of that downforce, okay? Okay, what else do we have here? The key frame is bedded too heavily when tapered, when the taper pin is as far back or as high as it can go. Again, this is another issue with the key frame pin. In this case, the key frame pin is too high. In this case, if you want to actually get the correct amount of downforce, you would actually go after the key frame pin. You can plug and re-drill that hole. Oftentimes, simply putting some veneer at the top of that hole and then reinserting the screw can move the pin down just low enough to achieve serviceability. If one really has to, although it's really not recommended, you could actually file the top of that cylinder that bears against the inside cutout of the key block to raise the overall mechanism. But I don't recommend it because you're gonna you know, roughen it up a bit. It's not gonna look great. It will be serviceable though, so people do what they need to do in a bind, and that's understandable. Another one, when the strike point is set, the brass screw protrudes from the key block and it interferes with the key slip. This is a common one that we can see sometimes if, again, it's not really the key block hardware itself, it's the position of our key frame pin. So depending on the position of that pin, the overall key frame can be adjusted forward, backward. We want to turn that brass screw in so that it's in the middle and then set up our key frame pin to that position. And of course, keep in mind what our strike point is. So a lot of the stuff with our German key blocks, if we're having problems, it isn't always the key block system, although they show us the symptom, but the cause is quite often the key frame pin. So we can change the pin location to be further forward or back, I guess. If we are, again, in a bind, it's conceivable that one could grind down that front face of the strike point screw, but again, that's really not recommended. It's not going to look great. You're, you know, whenever we have to get involved with a lot of material removal, especially when it's metal, it just is not an ideal situation. And we piano technicians tend to be a little bit more on the woodworking side than on the machinist side. So I'd recommend going the woodworking side as much as possible. Okay, so that pretty much concludes the troubleshooting of the German key block system. I'm gonna, again, stop the share and let's field some questions, shall we?
I'm gonna I'm gonna allow everybody to unmute yourselves so that you can it will speed the process. If you have a question, just unmute yourself and go for it, because I can't see everybody. Si, just go ahead.
If the key frame is bedded too heavily, would you shim under the front of the key block like you would under New York?
I wouldn't recommend it. I suppose that that it's a possible way to fix the problem, but there should be the ability for the key block, for the German key block mechanism to move. How far would that? I'd say probably a good 3/8 of an inch. It has a pretty wide range of adjustability. So most of the time you can achieve the correct bedding that you need within the system itself. But if you have the paper and you don't have the other tools, you're going to do what you need to do. It's still going to function for you if you were to treat it that way. It's just sort of a mishmash of the two systems, I guess.
And do both the Hamburg and New York key frame pins, are they both screwed into the key frame?
They are. I don't have one on me, but it is essentially The pin which you see is basically a continuation. It's a thread. It's a screw.
Yep.
So you may have seen on the Hamburg pin that there was actually a slot that you can actually screw it in with a screwdriver. For the New York keyframe pin, actually, it's much more difficult to insert, having kind of a square driver, which is, I forget what the actual width is to install. There's specialty tools that we have here in the factory to install them. You can install them with, say, a set of pliers if you're careful not to damage it or cause any burrs. But that is the same thing. It's a square pin followed by a screw.
Thank you so much, especially to let us know about that 3mm tool. That's a
Yeah,
very big help. Thanks.
Key to servicing those German systems.
Again, I can only see one of 2 pages here, folks. So if you have another question, just unmute yourself and go for it. Okay, well, I'm not hearing anything. Ben, this has been good. And I really do thank everybody for participating. This has been a good session, and I can say that I actually learned something again tonight. So
Thank you, Bill.
it's been good, and I hope to get this up and posted on the PTG page. That's another goal. I'm trying to stay ahead of myself, and with the board meetings and everything coming up, I'm running in circles. But anyway, it's all good, and I really appreciate everybody signing up and participating in this, and I hope to see everybody else on another one. So, Tom, did you have something?
Hi, I do have one question about the strike point. We never really got into the philosophy of that. Why is it in the factory that the strike line generally is absolutely straight? Yet we rebuilders often find that a bowed strike line yields a much better tonal quality. Your thoughts?
Yeah, so if I understand correctly, you're actually talking about hanging the hammers not in a straight line. Is that correct?
Correct, correct.
Okay, so there are 2 things. On New York Steinway's Model M, we actually do not hang the hammers in a straight line. The pianos which come out of the factory are hung in a slight bow to achieve the correct, the most optimal by average strike point. The challenge with trying to do something like that is it's quite easy on a as needed basis to tailor each strike line to get the optimal strike point. In a manufacturing environment where we're producing 5 pianos every day, we have to find a way that gives us the best tone for 5 pianos every day. And the easiest way to do that is to simply come up with a distance that works both on paper with our engineers, and empirically we're able to prove it to ourselves with our voicers in the factory. If we do have issues with voicing or with strike point, then something happens. For example, all of our Steinway Hall technicians a little more than 5 years ago were complaining about the strike point on the M's. And so they got our attention. We talked about it. We determined what that strike curve should be. And we're doing it like that now. Now, that being said, it's even a deeper question of what's going on from an engineering standpoint that there's a need for that. And that's above my pay grade. We have engineers at Steinway that look into those things and are trying to make sure that we achieve the correct tone with the straight strike points. But we also, at a place like Steinway, where tradition is very important, and we also have to be mindful of what the German factory is producing, so that we're unified. Generally speaking, we stick with a way that works well, by and large, on all of our models according to what we find works. Now, there's even another example on the Model D. In the treble section, I want to say we hang our hammers, it might be a 1/16 of an inch further up the shank. So we're certainly always mindful of good tone. We want to try to hang our hammers to have the correct sound, and we want to be able to do it in a way that is reproducible and consistent. That's actually a large part of what I do is, if we're going to change the strike point for hanging the M's, we have to be able to find a way to produce it consistently so that we can do that every time in a way that when we're making pianos, we can do it right and still do it well. So it's not that we're not mindful of it, but we also need to continue making pianos in a fashion that is predictable. So does that answer your question?
It does. Is part of the problem just the casting of the plate?
One could say that that the plate is a big element of it. The plate, as well as some of the belly work. Steinway continues to be one of the only manufacturers, Steinway New York for that matter, that still does its belly work by hand. Most other manufacturers, it's done purely by CNC and machine, and it certainly gives one a more accurate position when it comes to those things. But you know, Steinway is committed to still being craftsman-like, so we continue to do that here as well.
Well, thank you for everything.
Excellent. Any other questions before we looking real quick? Okay, Ben, thank you so much for this presentation. It has been marvelous, and thank you everyone who participated and stuck with us. I know it's running on late. It always runs on late, but this seems to be about the only time that we're able to have a time that works for everybody on the East and the West Coast. So I appreciate everybody's attendance, and I hope to see you for the next one. You'll all get a notice for that, and we'll go from there. So once again, thank you, and thank you, Ben, very much. You all have a good evening, and next time we'll see you then.
All right.
Thanks a lot. All right, appreciate it. Nice to see you.